Hi all. Welcome to the demo class on DevOps with AWS. Am I audible? Please confirm.
Yes.
Are you getting my screen? You are able to see my screen, sir?
Yes.
Okay, thank you. So this is a demo class on DevOps with AWS. So I am the trainer. My name is 𝐬𝐭𝐡, and I am certified as a Kubernetes application developer, that is a CKAD, and I got the certifications from AWS Solution Architect and Azure DevOps Specialist, that is AZ104, and I have around 10 plus years of IT experience. Coming to the today's agenda, so we will see what are the course contents we have. Means in our course, So what are the topics we are going to cover? Okay, so that all the topics we will see, and I will see what is the necessity of DevOps in SDLC, and what is the cloud computing, what is the necessity of cloud computing, why we are learning cloud computing. These things we are going to see in today's demo class. Okay, so if we come to the course contents, so the course will be around 45 classes. It will take around 45 classes, 45 plus classes. And in our course, we are going to cover the DevOps tools like Git, Jenkins, Ansible, Docker, Kubernetes, Terraform, AWS. Okay, so these are the tools we are going to cover from DevOps point of view. And from cloud point of view, so we have many clouds, right? We have Amazon Web Services, Azure, Google Cloud. So like that, we have many clouds. But AWS, Amazon Web Services, is the leading cloud platform nowadays. Okay, so we are going to cover Amazon Web Services, cloud computing also in our course. Okay, so before starting our course, the prerequisite to learn the DevOps is Linux. We need Linux basics. We don't need in-depth knowledge on Linux, but we need a Linux basics to work as a DevOps engineer. Okay, so for that reason, we are going to start our course with Linux. Okay, so we are not going to learn all the things about Linux. We'll cover only the basics, whatever the basics we need as a DevOps engineer. That basics we are going to cover in the Linux. Okay, so for our course will start with Linux. It will take around 4 to 5 classes, 4 to 5 classes to cover to complete all the Linux basics. Basics are enough. Okay, so basics means, so we are familiar with Windows operating system, right? So we know how can we create folders, directories, how can we create files. So these basic things we know on Windows. The same thing we have to know on Linux also. Okay, so for that reason, we'll start our course with the Linux, and we'll cover all the Linux basics in 4 to 5 classes. So once we did with Linux, we are going to cover Git. Git is a source code management tool. Okay, source code management tool. So why we are learning Git is this: by using this source code management tool, we are going to maintain the code from all the developers. So as a DevOps engineer, what we are doing is, we are not going to write any code. We are not going to involve in writing the code. We are not going to write any code. We are not going to develop any code. So developers will be there. Developers are going to develop the code. Okay. So development of the code will be taken care by the dev team. So dev team will develop the code. Okay. So here the code from the developers, whatever the code we are getting from the developers, that code we are going to maintain. Okay, we will have a different development teams. So the code from all the development teams we are going to maintain. So to maintain the code from all the developers. Okay, so we are going to use source code management tools. To maintain the code, we'll use a source code management tools. We have many source code management tools. So out of this, Git is very popular. It is very popular, and it is having many advantages compared to other tools. So nowadays, most of the organizations are using Git as a source code management tool. Okay, so we are going to start our DevOps course with Git. Okay, so that is to maintain the code. How can we maintain the code from our developers? Okay, so that thing we'll learn from the. Okay, so why we need this SCM tool is actually we have different development teams who are going to work on a different features. Okay, so in any software organization, what is going to happen is, so what is the every software engineer is going to work on some project, right? So what is the meaning of project? Project is nothing but development of an application and maintenance of an application. That is the main work of any software engineer, whether he is from testing team or development team or operations team, from whatever the team as a software engineer working. The main motto of any software engineer is to develop the code and to maintain the code. That is the main work. Okay, so here if we are working on any project, so what is the project? Project is nothing but development and maintenance of an application. So in real time we can see many projects, like we have on the e-commerce websites like Amazon. Okay, so we have Flipkart. So here, this maintenance of this application, development of these applications are our main work. Means any software engineer's main work is to develop an application and to maintain the application. So in this process, we will have many teams. Okay, to develop an application and to maintain an application, we will have many teams. Like we'll have dev team. So we'll have a testing team. We'll have testing team, and we'll have ops team. So like that, we will have many teams. Now, what this development team will do? Development team will develop them. Okay. So these development teams again will have different sub teams in the development team. Like every sub team will work on a separate feature. Okay, so let us consider in our project we have some three dev teams. Okay, so dev team 1 and dev team 2 and dev team 3. Let us consider we have three teams. Okay, so these three teams will separately work on different features. Team 1 will work on feature 1. Okay, so feature 1, I am considering the feature 1 belongs to, I am considering my project is some e-commerce website. Okay, I am trying to develop some e-commerce website. Okay, so every e-commerce website will have different features, like we are going to log in onto our application, and we are going to maintain the products, different products information in our application. Like that, different features will be there. So as of now, let us consider feature 1 is one belongs to login. So if any customer want to access our application, he has to log in, right? So for login, one we are going to hand over this login feature to one of the development team. Okay, so let us consider dev team 1 is working on feature 1. So what the feature we are considering here is a login feature. Similarly, dev team 2 is going to work on some other feature. So here feature 2, okay, so some electronic products. Just we are considering dev team 2 is going to work on the electronic products data maintenance. Okay, and we have another team, dev team 3. They are going to take care of feature 3. Okay, so some fashion related products they are going to take care. Okay, so like that we have different development teams. So these development teams, what they will do, they will develop the code, and once their code is ready, they are going to move the code to the SCM tools. Okay, so the purpose of these SCM tools is The purpose of this SCM course is to maintain the, that is the main purpose. Maintain the code maintenance will be taken care by the SCM tools, source code management tools. Okay, so in Git we are going to learn what is the necessity of this source code management tools. How can we maintain the code from different developers? Okay, and if we face any merge conflicts, how can we resolve the merge conflicts, and how to create different branches in the SCM repositories. Like that, we are going to cover the concepts from basics to advanced concepts like Git cherry pick, Git rebase, like that. Advanced concepts also we are going to cover with from the Git point of. Okay, so why we are learning Git is our work as a DevOps engineer is we are going to maintain the code from the developers. So for that purpose only we are going to learn Git. So we will learn the basics, from basics to advanced topics from the Git, whatever we need as a DevOps engineer. Okay, so here once we have the code, once we have the code, we have to work onto the code. Okay, where we have the code now? We have the code in our SCM repository. Okay, we have the code in the SCM tool. Our SCM tool has the code from our developers. We have three teams. Three teams are going to move their code into our SCM repository. Okay, so our SCM repository, SCM tool will have the code. Once we have code ready, we have to work onto the code. So to work onto the code, so we are going to use CI/CD tools. Okay, so what is this CI/CD means? Continuous integration and continuous deployment. That is the full form of CI/CD. So we have many tools which will act as a CI/CD tools like Jenkins, and we have TeamCity, we have Bamboo. Okay, like that we have many CI/CD tools in the market. So out of this, Jenkins is a very popular CI/CD tool, and 90% of organizations are using Jenkins due to many advantages. Okay, it has many advantages like it is rich in plugins, it has very good community support. Okay, like that, many advantages are there with the Jenkins. So due to these advantages, so many organizations are using Jenkins as the CI/CD tool. So for that reason, in our course we are going to learn about Jenkins. Okay, what is this Jenkins? So this is Jenkins is a CI/CD tool. Okay, so what this CI/CD tool will do? Now we have code in our SCM repository. Okay, so by using this code, we are going to build our project. Okay, so by using the CI/CD tool, we will build the project. We will build the code. So to perform the build, we are going to use CI/CD tool. Okay, that is a Jenkins. So in the Jenkins, we will learn that is how can we install Jenkins, and how can we create Jenkins mission, Jenkins server. And once the Jenkins server is available, here we are going to see how can we create different types of projects like freestyle project, okay, and Maven project, and a pipeline project. Okay, so again from the pipeline, so we are going to learn what is a scripted pipeline and what is a declarative pipeline. What is the difference between these two? Okay, so these things I will cover from the Jenkins point of view. Okay, so means in the Jenkins we are going to create a pipeline. Okay. So this pipeline will include all the stages, end-to-end stages from development of the code to the deployment of the code. Okay, we are going to implement complete pipeline, and once we implemented pipeline, we are going to automate our pipeline also. We'll automate our pipeline. Why we need to automate the pipeline? Because to reduce the manual intervention. Okay, instead of manually triggering our project every time. So if we automate our project at the defined time intervals, our project will be triggered automatically. So all these things we will see with the Jenkins. So the Jenkins, what we are going to do is we are going to take the code from our SCM repository. Okay, so we'll take the code from the SCM repository, and from this code we are going to perform the different operations, like we are going to compile our code, and we are going to perform the unit test cases. We are going to validate the test cases. Okay, and we are going to package the code. Okay, and we will perform static code analysis also. Static code analysis. So these are the operations we are going to perform from CI/CD tool. That is, with the help of Jenkins, we are going to compile our code. We are going to validate the test cases. We'll package the code. Once we package, we are going to get the artifacts for our code. So that all these things we are going to implement with the help of pipeline. Okay. So this in this pipeline, we'll define all the stages from development of the code to the deployment of the code. Every stage we are going to define, and by using these stages, we are going to perform these activities. Okay. So that is the purpose why we are learning Jenkins. Once we have Jenkins, okay, once we are familiar with Jenkins, we are going to learn about the containerization tools like Docker and Kubernetes. Okay, so why we are learning this Docker and Kubernetes is, so in the CI/CD tool, when we are using CI/CD tool, so once we did packaging for our application, we are going to get artifacts. We will get artifacts. So these artifacts are nothing but the jar files, like the jar or var files, var or year files, like a compressed files, some compressed files. Okay, so these artifacts we can deploy directly into our deployment service. These artifacts will be ready for deployment. Okay, so once we deploy our artifacts, okay, so our project will come into live. Okay, so once we deploy our artifacts, our project will come into live. So here, while deploying the artifacts, so we are going to follow two ways. Okay, so one is can directly deploy the artifacts. Directly, artifacts will be deployed. And another way is, instead of deploying artifacts directly, we are going to deploy images. Images will be deployed. Here, deploying artifacts directly, this is the traditional way of deployment. This is the traditional way of deployment. Okay. Nowadays, most of the organizations are going with deployment of the images. We are going to use images for the deployment. Images will be deployed. Okay. So here, how we are going to get the images? So in our CI/CD tool, we are going to get artifacts. Okay, so if we are deploying artifacts, we already have artifacts from the CI/CD. Okay, but if we want to deploy images, what we are going to do is we are going to get the images from the artifact. Okay, so artifacts will be converted into will be converted into images, and these images we are going to deploy. So these are the two ways of deployment we can perform. Okay, but while performing the deploy, while deploying our artifacts, if we are following the first method, that is, if we are directly deploying our artifacts, what will happen is, so this deployment of the artifacts depends on the environment configuration. Okay, so whether the deployment is going to success or failure, okay, the state of the deployment, okay, it depends on the environment configuration. So we know, so in any software organization we are going to have different types of environments like dev, sit, uat. Let us consider we have these environments. Okay, so most of the environments will have, most of the organizations will have environments like this. Okay, and here in the dev environment, dev people will work under the code, they will develop the code. Okay, and they will test the code in their environment. So the code will be developed by the developers itself, right? So developers will know what is the prerequisite for the code. Let us consider, so we need Java 11 for our application to run successfully. Now that prerequisite developers will know, because developers are going to develop the code, right? So they will maintain the required Java 11 in the development deployment servers, and they will deploy the code in the dev servers. So as the code meets the prerequisite Java 11, so our code is going to deploy successfully. Okay, so once the code got deployed successfully, so we'll get the sign off. We'll get the sign off to move the code to the next environment. Okay, what is the next environment? SIT environment. So let us consider in that is in SIT environment, who is going to take care? QA people will take care about the SIT environment. Now let us consider QA people don't know the prerequisite and they are maintaining Java 8 only. Okay, the QA people maintaining Java 8 only. Now the same code, whatever the code we deploy in development environment, dev environment, the same code we are trying to deploy in SIT environment also. But there is a change in the environment configuration. As even though we are using the same code, as there is a change in the environment configuration, our application is going to fail. Yeah, definitely it is going to fail, because the prerequisite for our application we considered as Java 11, but QA people are maintaining Java 8 only because they don't know about the prerequisite. Okay, so it is going to fail. Once our application failed, we are not going to get the sign off to move the code to the UAT environment. Ultimately, what happened to our production? Our production will be delayed. Production deployment will be delayed because we are not going to get the sign off for our code to move to the UAT environment. Again, QA people will notify this failure to the development environment. Again, the investigation is going to happen. Okay, so after investigation they have to find the cause and they have to rectify this, whatever the prerequisite they need, they have to rectify that, and after that only our code is going to uh, deployed successfully. So all these things will take time, and ultimately our production is going to delay. So if you observe here, so even though there is no code change required. Even though there is no code change required, so unnecessarily we are delaying our production. So that is the problem we are going to get if we are directly deploying the artifacts. Okay, means uh, without containers, no containerization. We are considering we are not going to use containerization technologies. Okay. Now consider the same artifacts, same code we have with containerization technology. Means we are using containerization technology in our environment, and we have the same environments like a dev, SIT, EAT, prod. Okay, and in dev environment, so if we are going with images, how we are going to get the images is by using the containerization modules like Docker. Okay, so to get the images, we have to use containerization technology, containerization tool like Docker. So with the help of Docker, okay, with the help of Docker, we are going to convert artifacts into images. So if we are implementing the containerization tools like Docker, okay, so this Docker will convert the artifacts. From where we are getting the artifacts? We are getting the artifacts from CI/CD tool, okay, from Jenkins. From Jenkins, we are getting the artifacts. These artifacts we are going to convert into images with the help of the containerization tools like that. Okay. Now, what this image will have here? This image will have, okay, image is nothing but a single package where it includes application code, okay, and the required binaries and required libraries and other dependencies, whatever we need to run our application seamlessly. Okay, that is nothing but image. How we are getting this image? With the help of the containerization tool like Docker. So Docker is going to create the image. This image will have the application code, binaries, libraries, and other dependencies. Whatever the environment configurations we need, everything will be embedded in the image itself. Okay, so as the image has all the required dependencies, so we can deploy these images directly in any environment without any issues. Okay, now let us consider we got the image. Okay, for our application, we got the image, and we are going to deploy our image into our dev environment. So we know we are let us consider we are maintaining Java 11, which is a prerequisite. So our application will successfully deploy in dev environment. Okay, and we'll get the sign off. And in SIT environment, we have Java 8. Let us consider. But even though we have Java 8 in SIT environment, the required prerequisite. What is the prerequisite? Java 11, right? So this the required prerequisite we are going to embed in the image itself. Okay. Now, as the image itself has the required configuration changes, our deployment is going to success irrespective of the environment changes, environment configuration changes. Okay. So no need to bother about the failures. Okay. So most of the cases, our code is going to be successfully deployed in all the environments from dev to production. So no delay. We are not going to get any delay. So within the defined time interval, we can do the production deployment. Okay. So that is the beauty of the containerization will happen if we are going with containerization tools like Docker. And to maintain the containers, we'll use Kubernetes. Okay, so that is the purpose why in our course we are going to learn Docker and Kubernetes. Okay, so once we are done with Jenkins, we are going to learn about Docker and Kubernetes. Why we are learning Docker and Kubernetes? Because to convert our artifacts into images and for to deploy our images into our deployment servers without any issues, we are going to learn the Docker and Kubernetes. So what is a Docker? Docker is a containerization tool. By using the Docker, we can create the images. From the images, we can create the containers. Okay, so we have many advantages with the containers. We'll discuss why we are going with the containers. What are the advantages we have? So all these things we'll discuss in the coming classes. Okay, as of now, why we are learning the Docker and Kubernetes means to easy our deployment, to reduce the number of failures, deployment failures. Okay, and to easily roll back to the previous versions. If we are going with this containerization tools, if we found any issues in the production, we can easily roll back to the previous versions, previous stable versions. Rollbacks are very easy. Okay. So like that, we have many advantages with the containerization tools. So with the help of Docker, we are going to create the containers. And why? What is the necessity of Kubernetes? So Docker is a containerization tool. Okay. Docker is a containerization tool. And what is a Kubernetes? Kubernetes is the container orchestration. Container orchestration tool. So what this Kubernetes will do is, Kubernetes, with the help of Kubernetes, we can maintain the containers. If we have hundreds of containers, okay, so maintenance of containers becomes difficult. Okay, so for that purpose, so to maintain the containers, we are going to implement Kubernetes. Okay, so while working with Kubernetes, we are going to create different types of objects, like we are going to create pods, and we are going to create replication controllers, replica sets, and daemon sets, and deployment objects. Okay, and we'll create config maps. Like that, many objects are there. So we'll see how can we create all these objects, and we are going to study about the health checks. That is a probes. Is the necessity of how can we implement probes. Okay, and horizontal part auto scaling. So like that, from basics to advanced topics. Okay, most advanced topics also we are going to cover with the Kubernetes. Okay, so once we done with the containerization tools, we are going to study about Ansible. What is this Ansible? Ansible is configuration management. Ansible is configuration management tool. So why we are learning this Ansible is, let us consider we have 1,000 servers in our organization. Okay, so these 1,000 servers, we have to do some patching activity. We have to do some software patching activity. Okay, so this patching activity will take, let us consider 30 minutes per server. Okay, so per server, if it is taking 30 minutes, so how much time we need for 1,000 servers? For 1,000 servers, it will take around 500 hours. If we do manually, okay, if you do this patching work manually, okay, so to complete the patching on all our 1,000 servers, we need 500 hours. And this is not feasible, right? So spending 500 hours just for patching activity is not feasible. Okay, so if we are going to implement Ansible for the same purpose to complete the same action, if we are going to use the Ansible, what will happen is, now what this Ansible will do is, the Ansible controller is going to connect all the 1,000 servers. Okay, there will be one controller. Ansible controller is going to connect all the 1,000 servers by using SSH. Okay, and it is going to execute some script, such that within 30 minutes, in all the 1,000 servers, okay, in all the 1,000 servers, our script is going to be executed. So he is going to execute the script, or Ansible controller is going to execute the script in all the 1,000 servers. How much time it will take? Just 30 minutes. You see how much difference, how much amount of time we are going to save here. Okay? Not only amount, the complexity also going to reduce. Like that operations. So like that operations, we can easily perform with the help of the configuration management tools. Okay, similarly, if you want to perform any copy operation, okay, if you want to copy any configuration files on all the 1,000 servers, simply we can use Ansible. Okay, we can copy the required configuration files within short duration. Like that, configuration changes we can implement with the help of Ansible. Okay, for that purpose, we are going to learn Ansible also in our course. Okay, so once we done with these tools, we are going to study about the cloud computing. That is one of the famous cloud provider, that is Amazon Web Services. So while learning with AWS, we are going to cover EC2 instance. How can we create EC2 instances? Okay, so we are going to learn about the EC2 instances and VPC and elastic load balancers and simple storage service devices, S3 buckets, and CloudWatch. And we are going to study about then RDS, relational database services, and IAM. So these are the services we are going to learn with the AWS, Amazon Web Services. When we are going to once we started with Amazon Web Services, we are going to learn these services. Okay, and we will include some more services also. Okay, so all services, whatever the services we need as a DevOps engineer, okay, all the AWS services we are going to cover in the Amazon Web Services cloud computing. Okay, so once we did with Amazon Web Services cloud computing, we are going to start with Terraform. So why we are dealing with the Terraform after cloud computing is because there is a dependency between cloud computing and Terraform. What is this Terraform? So this Terraform is an infrastructure as a code tool. Terraform is a infrastructure as a code tool. Okay. So in the cloud computing, when we are studying about Amazon Web Services, okay, so we are going to create all these services manually. Okay, we are going to create these services manually. We are going to create EC2 instances. EC2 instances are nothing but virtual servers, virtual machines, VMs. Okay, so we are going to create these EC2 instances manually, and virtual private cloud VPC is nothing but virtual private cloud. These VPCs also we are going to create manually, and load balancers also will create manually. Okay, and even EBS volumes. So EBS volumes also will create manually. So every operation we are performing manually only when we are working with the Amazon Web Service. Now, so if we want to automate this process, what process? The creation of the EC2 instances, creation of the VPC, creation of elastic load balancer. So these processes I want to do through the code, not manually from AWS. Okay, so without going inside the inside my console, okay, I want to create EC2 instance. Without going inside my AWS console, I want to create elastic load balancer. If that is the case, then we are going to implement infrastructure as a code tool like Terraform. Okay, so with the help of Terraform, so what we are going to do is we are going to write simple script. Okay, so once we execute the script, the required services are going to be created in our cloud provider. So the beauty of Terraform is this Terraform is going to work on any cloud, not only with AWS. Terraform will work with Azure, will work with Google. So every cloud provider. So if we are familiar with Terraform, we can work with any cloud provider. That is the beauty of Terraform. Okay, as there is a dependency between cloud computing and Terraform, we are going to start Terraform once cloud computing comes. Okay, so in the Terraform again, what are the services we created manually? Every service we are going to create with the help of script. We are going to write some simple scripts. Okay, so with the help of this simple scripts, we are going to create the required services in our Amazon Web Services console. Okay, so these are the tools we are going to cover in our course. So means what are the tools we are going to cover is, so our course is going to start with Linux because Linux is the prerequisite. So once we're done with Linux, we are going to learn Git. Why we are learning Git? Now we know what is the purpose of Git, because Git is a source code management tool. So to maintain the code from the developers, we are going to use Git. And once the code is ready, we are going to use CI/CD tool like Jenkins. Okay, and in the Jenkins CI/CD tool, we are going to get the artifacts. These artifacts we are going to deploy with the help of containerization tools, that is a Docker and Kubernetes. Okay, and for configuration management, we are going to learn Ansible. So like Ansible, we have some other configuration management tools also, like Chef and Puppet. But compared to them, Ansible is very simple. You can easily learn. Okay. For that reason, we are going to learn about the Ansible. And once we did with Ansible, we learn cloud computing and Terraform. These are the sequence of tools we are going to learn in our. Okay. So any doubts up to now?
Yeah, hi. This is Tejeshwar, and I wanted to check, are we going to cover Azure here in our course?
Which one?
Azure.
No, only AWS. So if you are
Oh,
familiar with one cloud, so you can easily work with other clouds also. We are dealing with
oh,
AWS because nowadays AWS is the leading cloud provider.
all right. All right. Thanks.
Any more doubts? Are you clear? So along with this course, we'll provide recording videos and notes also. We'll provide for every tool. We'll provide notes also. Yeah. Any doubts? Alisha, Harika, Elvis, Nagarjuna, Ravalika. Okay, thank you. Thanks for attending that.
Thank you. Thank you.